For a person 6 feet tall walks at a speed of 5 feet per second. Doesn't seem realistic, but let's just accept it. Toward the light that is 20 feet above the ground. So the picture is that you have a 20 feet lamppost. So there's a light source on the top, and then it's shining. And here's a guy. And he's walking towards to the lamppost. Now, of course, this is dark. This will be his shadow. And the question is, at what rate is the tip of his shadow moving? So as he's going towards to the lamppost, this is also going to be moving, right? So we want to find out the speed. And B, at what rate the length of his shadow changing? Well, the shadow will become smaller, so shorter, so the answer should have a negative sign. Okay? Sometimes, depending on the variable that you assign, the signs come out in the wrong way. So, for example, the tip of the shadow is walking along with the man. So, I mean, negative is not wrong in this case if you think that this side, this direction is a negative direction, that's the positive direction. Or if you drew the picture on the other side, okay, it's not wrong, but I would prefer the speed to be positive as it's going. So I would prefer that, especially because the man's speed is 5 feet per second that way. Okay, but I want this b to be negative. All right. So here, it's a word problem, so you have to come up with your own variables. And to come up with a variable, you need to have a simplified geometric picture. If you don't, then it's really hard to figure out what's going on. So I'll just draw this right triangle from here, and there's the man and the shadow. So I think something like, here's the man, which is 6, this is 20, and this is the shadow, so we want this to be x. So that's the simplified one, where these are both right triangles. And another thing that I want you to tell you is that a lot of times when you have triangles, the formulas that you end up using are either the Pythagorean theorem, or if you have two triangles, you want to use that the two triangles are similar, so you can talk about the ratios being same. Okay, so those are the two sources where you can have the relationship between the variables. For this question, I don't think the hypotenuse is that important. We are only concerned about this, right? X and then this length, right? So you can choose. There are two options. You can choose y to be just this other length, because you have to somehow talk about the person moving towards the lamppost, and how do you talk about the speed of a person? You have to think about the change in distance with respect to some fixed item, right, which is a lamppost here. So y is a good choice. Having y here is a good choice. And also, since you're thinking about the speed of this tip of the shadow too, and you want to also measure the speed of this by thinking about this distance, I think taking z to be the entire thing, that's not bad either. Okay, and you can actually solve this question without introducing z, or you can even solve this question using just x and z and representing y as z minus x. Yeah. But okay. Yeah, and thank you for that. Okay. So another really important question is, important thing that you have to know is that I talked about this word when, related rates. Okay, so whenever you see a related rate question, it's a good habit to read the question and find this word when and circle it or just mark it somehow. Okay, because on the picture, this number, when he is 10 feet, when y is 10, that should not be on the picture. Do not put this number on the picture because this number should only be used after you differentiate. You get it? Okay. So you need the relationship as it is to differentiate, and only after you differentiate, this number can be safely used. Okay, so it's very important to find this word, and whenever you find this word, see what numbers are relevant to this when, and just maybe underline those numbers so that you know that you're going to use it later, not in the beginning. Okay. All right. So, but 6 and 20 is a fixed number for the entire thing. It never changes. So when something never changes, then you use the number. That's the thing that's kind of hard in the beginning. In the beginning, when you first solve related rates, it's hard to decide when you put the number and when you put a variable. Well, you put a variable if it changes. You put a number if it doesn't change. Okay. And when you see this word when and some number, this should never be on the picture. Okay. Now let's try, and for us, we'll use x, y, and z, everything. Okay. Now let's try this. We have two right triangles, so we can talk about their relationship. Okay. So, what 6 is to x is
what
20 x plus y.
20 is 1 x plus y.
What 20 is x to x plus y or
Z.
z? So we're going to use x, y, and z. And whenever you have rate equals to rate, you can cross multiply. So you have 6z equals to 20x. And then, in addition to this, what's the relationship between z and x and y? Z is
X plus y.
x plus y. Okay, good. So we have one relation, we have another relation. Sometimes you may have more than one. Doesn't matter. Just differentiate everything that you see, okay? So that you can have the relationship between their derivatives. Okay. Now, what's the question? First question is, at what rate is the tip of his shadow moving? Oh, I should have written this down as the derivative. Okay. So, not only rate of change is the derivative, speed is the rate of change of the position, right? So 5 feet per second, that's rate of change. But in this picture, 5 feet per second is rate of change of what? He's moving, right? It's the rate of change of what?
Time?
No,
Per
time.
second?
Feet per second, it's the rate of change of some position or distance or length per time with respect to time, okay?
Right.
So what length in this picture is changing?
dy dt.
dy dt, right? It's dy dt. As he's moving towards to that, y is shrinking. So that 5 should be translated to dy dt is?
-5.
-5, thank you. That was actually the thing I wanted to say. It's negative because it's going towards
It's
20, therefore it should be shrinking. Okay. Right, so that's what's given. So that's given. And then let's try to figure out what A is asking. At what rate is the tip of his shadow moving? So what is this A asking for? Change of what? The tip speed is the rate of change of this length, right? So part A is asking for dz dt. When what? Y is 10. That's what A is. Okay? Now question B, how do you write question B? What rate is the length of his shadow changing? dx dt. This is the shadow length, right? So the question is dx dt when y is 10. So these are the questions that are being asked. Okay? So in fact, this much here captures everything that we wrote here. So now we don't have to worry about this at all. We can now just solve this question. Okay? All right, so let's actually do the solving now. Let's differentiate. So what do you get? If you differentiate z, you get dz dt. And if you differentiate x, you get dx dt. And then if you differentiate z, you get dz dt. Differentiate x, you get dx dt, dy dt. And then, all right, so here I have dy dt as negative 5, right? So this is negative 5. So I have, this is negative 5. So I have dz dt is dx dt minus 5, which can be plugged into here on the left side. So that 6 times dx dt minus 5 is 20 times dx dt. Then multiplying this out, you get 6 dx dt minus 30 is 20 dx dt. And moving it over here gives you 14 dx dt equals to negative 30. Then solving for dx dt gives you dx dt. So solving for dx dt, you can solve it by dividing by 14, right? 14. So negative 30 divided by 14 gives you negative 15 over 7. And then what about dz dt? You can now plug that in here, right? So dz dt is negative 15 over 7 minus 5. That's 35 over 7. So negative 15 minus 35, that's negative 50 over 7. In both cases, you should put numbers there, units there. So what's the unit for this answer? It's a speed.
Feet per second?
So this is the answer to part A, right? A should, and actually we prefer the positive one, so we write 50 over 7 feet per second. And that's the answer for B, right? And it also is feet per second because it's the rate of change of the length. That's how you do it. So I mean, this much is just calculating, so if you believe that at some point you will get the answer after lots of calculation and substitution, at some point you will get the answer. You just have to just do it. I guess the real challenge is to actually assign variables and to come up with a relation.